scientific subject called density and buoyancy. Buoyancy is where the water will push you up. Because the density is less than the buoyancy, so the buoyancy increases. Well, density is the amount of mass in an object where if it's denser than what it is placed in, it will go straight through it and it'll break through it. So, density increases if you scrunch up something and put it in that area, it'll probably sink. It might not, but it probably will. While if it's spread out, the density decreases because it has places to move. Now, let's get our experiment. Objects. So, as you can see, if you place movement, if you place them alone in the water with no extra weight or anything added to them, they will float by themselves. Now, these do not dissolve, so don't worry. Now, they float because there's not a lot of density, and as you can see, they're spread out in more of a U shape. So, buoyancy is increased, allowing the other objects to float. But if they still have a certain amount of density in them, if you add some extra weight to them, they'll sink. What is buoyancy? Buoyancy floats you up like this. Once it's spread it up. Now. Alright, Nick, here's your part.
But
when something is not spread out and it's crushed together, then it doesn't float as much.
why is that? What happens with its density when it's crushed together?
Because it increases the amount of density in that space.
Very good, very good.
From the sticker, it's a cat. As you can see, Nick, you're the experiment guy for this one. Hold the experiment, okay? Not the cat. Ah, that's where you were. Okay. Okay. Please hold the sticker. Okay. Anyway, as you can see, our lovely Nicholas here is holding the experiment. These objects will all sink, because they have more density than the water, but some will slowly sink and some will sink rather quickly because their density varies as they're not the same object. So Nick, put down the net. The net. It'll slowly but surely sink, I think. It does last time. I'll help it out. It is still sinking. It will not rise again because its density is greater than the buoyancy trying to push up on it.
Okay,
As
very
you
good.
can see with our floating objects, the case is definitely not the same because by itself, the buoyancy is stronger in its sense. Now, let's drop the goggles and see how fast they sink. They're sinking already faster than the net, but still, they'll need a little help to get to the bottom super quickly. Both of these objects are not designed for sinking, so the buoyancy still stands up a little flat, but overall the density will win. Now with this object in particular, it is built to sink, so we'll see how fast this sinks. It's sinking faster than the others. And it is going straight down, taking a straighter route. Because its density is built to have the greatest, and it is built to penetrate the water's buoyancy. So, compared... Did that move? We need to get all of our objects. That moved. We'll have to explain this part. So, comparing these objects, some will sink and some will float. density and buoyancy. Now, why, Nick? Oh. Why, Nick? Well, the density and buoyancy, why will these objects sink and these will float? What's the comparison and what's the difference?
This are longer. They're spread out more.
So they have less
Density.
and the buoyancy wins that one. So what about those? What about those objects, Nick?
They have more density so that they go down instead of floating.
Are you guys taking questions? Are you taking questions?
Huh?
Are you going to take questions?
What's that?
Meaning, are you going to answer some questions from the audience?
What questions do you have?
Does density and buoyancy have?
All right, Nick.
Do
What
you remember?
think?
They have a
What are density and buoyancy?
they are opposite.
An opposite relationship.
So
between
if density increases, what happens to buoyancy?
it decreases.
And if density decreases, what happens to buoyancy?
It the buoyancy upgrades.
No.
Increases. Very
Yeah.
good.
Wait. Yes. Okay.
So if two objects were the same size, they took up the same amount of volume.
Huh?
If two objects took up the same amount of volume, but one was made out of lead and one was made out of foam, what would the lead do?
It was good
Why?
because the lead has a more density than the foam, and it has more mass.
Okay, very good. Now what would happen if I were to take that ball of lead and spread it out to make it very, very, very thin?
It would float because the density is spread out and it's not all hooked up in one space to penetrate the water.
Very good, very good.
Where's our explanation 1 to 10?
Very good.
Yep.
If I had two objects of the same size, one was lead, one was foam, what would happen?
The foam would float and the lead would sink
Why?
because the foam has less density than the lead.
All right, now if I were to take that lead and I were to spread it out and make it really, really, really thin and keep spreading it out, and I put it in a big pool, what would happen?
It would float
Why?
because when it's spread out, the density lowers.
Very good, very good.
This concludes our presentation for density and buoyancy.